Hello everyone. Today we are going to solve some 7 marks in mathematical induction. Right. Today what is the sum we are going to solve? We are going to solve prove that 1 cube plus 2 cube plus 3 cubes goes on up to n cube, which is equals n squared multiplied by n plus 1 the whole square divided by 4. Shall we start to solve? Yes. So to solve this we have to go through 3 different steps. So what is the first step? So I am going to take the entire thing equals p of n. Let p of n equals 1 cube plus 2 cube plus 3 cube and goes on up to n cube, which is again equals to n squared multiplied by n plus 1 the whole square divided by 4. Right, as we are going to solve this, prove this by using mathematical induction, we have to solve it for n equals 1 first. Right, so I am going to put n equals 1. So p of n equals 1. Right. So first we are going to solve for left hand side. Right, so p of n equals 1. Here n is what? N is the number of elements in a series. So n is 1. So it will contain only one element and it is the first element. So what is the element here? 1 cube. So 1 cube is equals 1. Right. Now we start solve for right hand side. So what is the right hand side? P of n. So I will put n equals 1. So p of 1 equals, we have to take this entire term as right hand side. In place of n we have to substitute 1. So n squared, so 1 squared multiplied by n plus 1 the whole square. So in place of n I will put 1. So 1 plus 1 the whole square divided by 4. N 1 squared is 1. 1 plus 1 is 2. 2 squared divided by 4, which is equals 1 multiplied by 2 squared is 4 divided by 4. So we can cancel this. It's multiplication. 1 4s are 4, 1 4s are 4, it is equals 1. Right. So now from both of the things we know that right hand side is equal to left hand side. So what we can know? We can know that the statement is true. The statement is true for n equals 1. Right. So what is the method of mathematical induction? So if you are going to prove something by mathematical induction, so the statement has to be true for different numbers of n. So initially we put n equals 1. So this is the first step, right? So first step is what? We have to put n equals 1 and we have to verify both the left hand side and the right hand side are equals. So it is equal. So we can say that the statement is true for n equals 1. So what is the next step? So the next step is we are going to assume the statement is true for n equals k. We are going to assume the statement is true. True for n equals k. See, we already find the statement is true for n equals 1. Now we are assuming the statement is true for n equals k. Clear. So we are taking that p of k equals 1 cube plus 2 cube plus 3 cube and goes on up to k cube, which is equals k square multiplied by k plus 1 the whole square divided by 4. Clear. This is the second step. So what is the third step? Third step is we are going to add another term. So what is the next term? So here k is the final term. So what will be the next term? So the next term will be k plus 1. So now I am adding. So this is the third step. So third step is adding k plus 1th term on both sides. Right? Right. And we are going to check if we take the k plus 1th term, this equation whether this equation behaves in the same manner or not. Right? Right. So now we have to find what is the k plus 1th term. So p of k plus 1. So it will be, what is the kth term? So the final term here is k cube. So what will be the kth term? So k plus 1th term is, here what is, k is the final element. Here this term is k cube. So k plus 1th term will be k plus 1 cube. Right? Now I am adding k plus 1 cube on both sides. So what we decided to do? We decided to do the k plus 1th term on both sides. For we are doing that, we have to know what is k plus 1th term. So k plus 1th term is, here kth term is k cube. So k plus 1th term is k plus 1 the whole cube. Right? Now we are adding k plus 1 on both sides. K plus 1 cube on both sides. So p of k plus 1 equals 1 cube plus 2 cube and goes on up to k cube. Now we are adding k plus 1th term. What is that? K plus 1 the whole cube, which equals, what we have here, k squared multiplied by k plus 1 the whole square divided by 4. So what is the left hand side? So left hand side is this one. So we take this one and we add k plus 1 the term, that is k plus 1 the whole cube, which equals, what is the right hand side? It is k squared multiplied by k plus 1 the whole square divided by 4. So we have to add k plus 1 the whole cube on this side too. So I am going to add k plus 1 the whole cube. Clear? Clear. Now we see, here it is also k plus 1 the whole square. Here it is also k plus 1 the whole cube. So I am going to take k plus 1 the whole square in common. So it will becomes k squared plus, here k squared divided by 4 plus k plus 1. Clear? Clear. So now we are going to solve again. So I am keeping this k plus 1 the whole square as it is. I am cross multiplying this one, the 4 with this one. So it will becomes k squared plus 1 k multiplied by 4 will be 4k plus 1 multiplied by 4 will be 4 divided by 4 in common. Right? Right. So I keep k plus 1 the whole square as common, not as like that of previous step, and k square as it is. I am going to replace this 4k as 2k plus 2k, right, plus 4 divided by 4, right, right. So k plus 1 the whole square multiplied by, I am going to take k. So here also k squared, it contains k, here also 2k, it contains k. So I am going to take k as common. So it will become k plus 2, okay, plus, in this term it is 2k, in this term it is 4. Both terms have 2. So I am going to take 2 as common. So 2 multiplied by k plus 2, clear, divided by 4. So now k plus 1 the whole square remains the same. Now watch, this both terms have k plus 2, clear. So I am taking this k plus 2 as common. So it will becomes k plus 2. So what remains here? K plus, what remains in this term? 2 divided by 4, right, right. So k plus 1 the whole square plus, Here k plus 1 multiplied by k plus 1 will be k plus 2 the whole square divided by 4. Right. So I am going to just rewrite k plus 1 the whole square equals. So I am going to replace this 2 as 1 plus 1, like k plus 1 plus 1 the whole square divided by 4. So it's multiplication, right? Why should I put addition? So here k plus 1 the whole square. Here k plus 2 multiplied by k plus 2. Here it will becomes k plus 2 the whole square. So k plus 1 the whole square as it is. So I am just replacing this one, right? We can write it here too. So it will be k plus 1 the whole square multiplied by k plus 1 the whole square divided by 4. I am just keeping a bracket here so that we can easily identify it as the p of k plus 1. So it is p of k plus 1. Clear. So what we got here, p of k plus 1 equals k plus 1 the whole square multiplied by k plus 1 the whole square divided by 4. So what is p of n? So p of n equals n squared multiplied by n plus 1 the whole square divided by 4. So watch this closely. If you substitute p equals k plus 1, so it will becomes, this term will becomes k plus 1 the whole square. This also happens here, and this term will becomes k plus 1 the whole square divided by 4. So from this we can conclude that this statement is true for the value n equals k plus 1, right? Clear. So from this I can say that the statement is true for n equals k plus 1. Clear. So now we can say by using mathematical induction, right? By using mathematical induction. What is mathematical induction? If you have to prove something, we are taking the same equation in different values of given n, and we proved this. So we are writing that by using the mathematical induction, we can say this statement is true for all n belongs to natural numbers, right. So in this sum they ask us to prove one thing. So what is this thing? That is, they ask us to prove 1 cube plus 2 cube plus 3 cube and goes on up to n cube, which is equals n squared multiplied by n plus 1 the whole square divided by 4 by using mathematical induction. What is mathematical induction? In the given equation they said it is true, so we have to prove it is true for all the n belong to natural numbers. So we check it in 3 steps. What is the first step? So first step we have to verify this. So we put n equals 1 and we find both the left hand side and right hand side are equals. Yes, it equals it. So then we write this statement is true for n equals 1. Then what is the second step? We assume that this statement is true for n equals k, right? Then we add k plus 1th term on both sides and verify this statement is true or not. This statement, whether this statement is behaving in the same manner or not. Then after doing some simplification, we find out that this statement is behaving in the same manner as like that of a given equation. So we say that this statement is true for n equals k plus 1. So we finally write by using mathematical induction, the statement is true for all n belongs to natural numbers. Clear? Shall we move to the next sum? Yes. So So what is the second sum? The second sum is also they ask us to prove using mathematical induction. So what they ask us to prove? They ask us to prove 1 divided by 1 multiplied by 3 plus 1 divided by 3 multiplied by 5 plus 1 divided by 5 multiplied by 7, and it goes on up to 1 divided by 2n minus 1 multiplied by 2n plus 1, which is equals n divided by 2n plus 1. This is what they ask us to solve. Shall we? Yes. So we have said that we have to do it using mathematical induction. So that, what is mathematical induction? So if you have to prove something using mathematical induction means we have to put these things in a different value of n, and we can finally conclude yes, for all values of n the equation behaves in the same manner, then we can conclude the equation is good. This equation is true for all values of natural number, right? Right. So to initiate this, we are going to take the entire equation as p of n. Let p of n equals 1 divided by 1 multiplied by 3 plus 1 divided by 3 multiplied by 5 plus 1 divided by 5 multiplied by 7, and goes on up to 1 divided by 2n minus 1 multiplied by 2n plus 1 equals n divided by 2n plus 1. Right? Right. As I said, this sum contains 3 steps. First step is we have to check this equation behaves properly for, whether it behaves properly for n equals 1. So shall we check it? Yes. So I am putting n equals 1. Right? Right. So I am taking the LHS first. LHS equals, so P of 1. So P of 1 means the entire term contains one first element only, right? So what is the first element? 1 divided by 1 multiplied by 3, which is equals 1 by 3. Clear? Clear. I am taking the RHS. So here P of 1. So here n equals 1. What is the right hand side? N divided by 2n plus 1. So now we know n equals 1. So 1 divided by 2 multiplied by, in place of n we have to substitute 1 plus 1, which is equals 1 divided by 2 plus 1, which is equals 1 divided by 3. So now we can know that LHS is equals RHS. So this statement is true for, the entire equation is true for n equals 1. So I am writing this now. So LHS equals RHS. So we can say the statement is true for n equals 1. Clear? Clear. I hope you all clear with this one. Hereafter the sum is much more similar to the previous sum. So I want you to solve this along with me, and if you have any doubts you can stop and watch this again, but you have to try to solve on your own, right? Clear? Clear. Shall we move to the next step? Yes. So what is the next step? Good. So the next step is we are going to assume one thing. What is the thing? Yes, we are going to assume the statement is true for n equals k. Shall we do that? Yes. So now we are going to assume the statement is true for n equals k. Write along with me. Assume that the statement is true for n equals k. So it will becomes P of k equals 1 divided by 1 multiplied by 3 plus 1 divided by 3 multiplied by 5 plus 1 divided by 5 multiplied by 7, and it goes on up to 1 divided by, in place of n we have to put k. So 2k minus 1 multiplied by 2k plus 1, which is equals k divided by 2k plus 1. Clear? Clear. So now we assume this one. So what is the next step? Come on, recall it from the previous sum. So what we did? Yes, of course. We are going to check whether this given equation behaves in the same manner as like that of given when we do it for k plus 1th term. So to check this, I am adding k plus 1th term on both sides. So we have to know, we decided that we have to add k plus 1th term on both sides, and we have to check whether the given equation behaves in the same manner or not. For this, we have to know what is the k plus 1th term. Shall we do that? Yes. So what is k plus 1th term? Equals, so in place of this is the last term, this is the kth term, right? Right. So now we are moving for k plus 1th term. So what we have to do? We have to do is replace k. So this is the kth term, right? So we are going for k plus 1th term. So replace all the k's here with k plus 1. Shall we do this? Yes. So it's divided by 2 k plus 1 minus 1 2k plus 1 plus 1. So this is the k plus 1th term. Clear? Okay. Shall we simplify this? Yes. So 1 divided by, I am going to take this 2 inside this k plus 1. So it will becomes 2k plus 2 minus 1 multiplied by 2k plus 2 plus 1. So it will becomes 2k. So plus 2 minus 1 will be plus 1. Plus 2 plus 1 will be plus 3. It will becomes 2k plus 3. Right? So now we know k plus 1th term is this one. So now we are adding this term on both sides. So what is this term? 2k plus 1 multiplied by 2k plus 3 on both sides. Clear? Clear. So shall we add? Yes. Now we are going to take p of k plus 1 equals. So what is the left hand side? This one, right? So I am writing this. I am taking this one. 5 plus 7, it goes on up to 1 divided by 2k minus 1, 2k plus 1. Right? Now we are going to add this to the left hand side first. So it will becomes plus 2k plus 1 plus 2k plus 3. Right? Which is equals. Now we are going to add this term to the right hand side. What is already in right hand side? What we have already in right hand side is k divided by 2k plus 1. Right? Right. Now we are going to add this term to the right hand side, which is 1 divided by 2k plus 1 multiplied by 2k plus 3. Clear? Clear. If we take both the things, 2k plus 1 is common in both their denominators. So I am taking this out. So 1 divided by 2k plus 1. Right? Right. So what we have remaining? K plus 1 divided by 2k plus 3. Clear? Clear. Okay. So now we are going to cross multiply this one with k. So it will becomes 1 divided by 2k plus 1 multiplied by k multiplied by 2k plus 3 plus 1 divided by 2k plus 3. Clear? clear. So it will becomes 1 divided by 2k plus 1. It will be, I am multiplying this k within this elements in the bracket. So it will becomes 2k squared plus 3k plus 1 divided by 2k plus 3. Right? Right. So I am again rearranging this equation. That is 2k squared, right? I am going to rewrite this 3k as 2k plus k plus 1 divided by 2k plus 3. Clear? Clear. So the equation will becomes 2k plus 1. So here this both terms contains 2k, 2k. So I am going to take this 2k out. What will remains here? It is 2k squared. We are taking 2k in common. So k remains common. So here it is 2k. We are taking out 2k. So 1 remains. Okay. Okay. So this term I will keeping this k plus 1. Right? Right. So divided by k plus 3. 2k plus 3. So from these two terms, so how it becomes like this means I am just taking 1 as common from this k and 1. So I am taking 1 as common. It will remains k plus 1. Okay. So this term will also contain k plus 1 term. This term is also contain k plus 1 term. So how it comes? It comes from this equation. Here we take 2k as common. So the remaining terms will be k plus 1. Here from these things I take out 1 as common. You can write it clearly. So we are taking 1 as common. So it will become k plus 1. Right. So what we are going to do now is 1 divided by 2k plus 1. Now we am taking k plus 1 on both sides as common. So it will become k plus 1. So if we take k plus 1 from this equation, from this thing, it will remains 2k plus, if we take k plus 1 from this, it will remains 1 divided by 2k plus 3. Clear? Clear. So we have 1 divided by 2k plus 1 multiplied by k plus 1 into 2k plus 1 divided by 2k plus 3. These terms are in multiplication. So I can easily cancel out this 2k plus 1 and this 2k plus 1. So what will remain? So what will remain is k plus 1 divided by 2k plus 3. Clear? Clear. Now I am again rewriting this equation. K plus 1 divided by 2k, this 3s plus 2 plus 1. Right? Right. I am writing this 3 as 2 plus 1. So now I am taking these 2 in common. So it will becomes 2 multiplied by k plus 1 plus 1. Okay. So it will becomes p of k plus 1 equals k plus 1 divided by 2 of k plus 1 plus 1. Clear? Clear. So what we have now is p of k plus 1 equals k plus 1 divided by 2 multiplied by k plus 1 plus 1. So what is p of n? P of n is n divided by 2n plus 1. By comparing both of things, this equation is true for n equals k plus 1. So see, what is n? What is here n? What is here k plus 1? So if we put k plus 1 instead of n, it will becomes, this equation will becomes like this only. So numerator n will becomes k plus 1. In denominator 2 remains the same. N will becomes k plus 1 plus 1. So from this we can say this statement is true. This statement is true for n equals k plus 1. We can say that the statement is true for n equals k plus 1. So now we can say by using mathematical induction, What is mathematical induction? Mathematical induction is, if we are provided with an equation, we have to make that equation true by substituting the various values in this equation. So we can say by using mathematical induction, the statement is true for all n belongs to natural number. So see, we are provided with an equation, right? That is 1 divided by 1 multiplied by 3 plus 1 divided by 1 multiplied by 5, and it goes on up to 1 divided by 2 n minus 1 multiplied by 1 divided by 2n plus 1 equals n divided by 2n plus 1. So we have to prove that. So what we did, so we are using mathematical induction. What is mathematical induction? We have to prove this equation is good and behave properly for all values of n which belongs to natural number. So that we put the equation with n equals 1 and n equals k and n equals k plus 1. Right. Initially we take n equals 1 and we literally verified by using, because n equals 1 means we are going to take the only one term in the series, right? So we can easily verify that one. And what we do next is we assume that this equation is doing good. This equation is true for n equals k. And what we do next? So we are going to check beyond that. So we are going to add k plus 1th term on both sides. Remember, we are not adding k plus 1. We are adding k plus 1th term on both sides, so that we find the k plus 1th term and we add to the both sides and we simplify the right hand side, and we finally check this p of k plus 1, which is much more similar to that of given equation of p of n, which is n divided by 2n plus 1, right? So while comparing that equation to this equation, we can say that the statement is true for n equals k plus 1. So finally, comparing all those three steps, we can finally say that by using mathematical induction, this statement is true for all n belongs to natural numbers. Clear? Thank you guys.